In today's episode of Chemistry Made Easy, we will try to get an overview on the chemical bond formation as such. It will be about strong chemical bonds, not the weaker ones like van der Waals interaction and hydrogen bridging bonds. First of all, let us have a look at the ionic bond. For ionic bonds, we have cations and anions. They will interact electrostatically and will form a crystal lattice. On the other side, we have the metallic bond. It consists of metal cations which are surrounded by some kind of electron gas. These electrons are responsible for the conductivity of the metal. For organic chemistry, the covalent bonds are certainly the most important. And for covalent bonds, we have an atom X and an atom Y, which are connected by a common bonding electron pair. It's not a free electron pair. The electron pair is responsible for this bond. If X is more electronegative compared to Y, then this bond will be polarized. If the difference in electronegativity is very high, then, this electron will finally belong to X, and then we have here an anion, there we have a cation, and this is the same as that. Then we have an ionic bond. So, there are bonds somewhere in between ionic and covalent, but in organic chemistry, let's say, covalent bonds are predominant. So, how can a covalent bond be formed? For instance, we could have a radical X and a radical Y. One radical electron, another radical electron make a combination, and we have the bond formed. This is generally not a very selective process because, in principle, two X radicals could react with each other. The same for the Y radicals, and we have the selectivity problem. This combination of two radicals works very well if both radicals are identical from their structure. Second possibility, we have an anion X and a cation Y, and this free electron pair will form the bonding electron pair. It is a reaction from a situation like that to a covalent setup. And the third possibility is that while this bond is formed, another bond is sacrificed. So we start again with the anion X, and now we have not a cation as reaction partner, but another molecule which has a bond between Y and Z, which might be polarized, delta minus here, delta plus there, and a substitution takes place. Z minus with a free electron pair is set free. Especially interesting in organic chemistry are reactions where double bonds are involved. Let's have a double bond between the centers or atoms Z and Y, which could react, for instance, with an X radical, then a bond between X and Y would be formed. One bond between Y and Z is sacrificed, and a radical electron will remain at the center Z. X could be a cation, then this would result in the formation of this moiety with a cationic charge at the center Z. And if X is an anion, then we would get to this result. There is another kind of bond formation, which is especially interesting, and that are cycloaddition reactions. Cycloaddition reactions can lead to 3-membered rings, to 4-membered rings, 5, 6, even 8-membered rings. The most renowned example is the formation of 6-membered rings. Let's assume we have a double bond between the centers X and X prime, and we have another system conjugated with 2 double bonds between the centers Y and Z prime and Y. Then a cycloaddition could occur all centers connected in a 6-membered ring. The famous Diels-Alder reaction would fit into this scheme, and these reactions are especially interesting because highly complex structures can be formed in just one reaction step, And moreover, all atoms or all centers of a starting material are included into the product. Such reactions are called highly atom economically. Thanks for listening.